In this video, we are going to take a look at integrating with respect to the arc length. So arc length is denoted by S, and this is a variable that's used to figure out lengths of curves. And if you are just integrating one, then you are basically finding the length of the curve. So curve is just some curve in 2D or 3D, doesn't matter. If you're integrating one, you're finding its length. So just to show you why that's true, and by the way, the formula for ds to switch it to a regular integral, given parameterization, so you have some sort of parameterization for your curve, x equals x of t, y equals y of t, and z equals z of t, right? So this is some sort of parameterization, and t goes from a to b. And let's say you want to switch this integral with respect to arc length to a regular integral, right? The one that you're familiar with, like a regular definite integral. So then what will happen is you're going to have a for the lower bound, b for the upper bound, where that's how the parameter changes. And if you're integrating one, then you just need to transform ds. And ds is transformed by taking the square root of x prime squared plus y prime squared plus z prime squared if it is a three-dimensional situation, and then you got dt. Okay, so that would be the formula for the arc length. So just again to show you why that would be true, which of course is not a proof, but just kind of like a feeling, does this make sense? So imagine that this is a circle, right? So a circle, you should know that the parameterization for a circle, let's say radius of the circle is 3, would be 3 cosine t and 3 sine t. Now, this is not the only parameterization for a circle of radius 3, but it is a parameterization. We just need one. Okay, sometimes I call it standard. So t here would be from 0 to 2 pi. It doesn't matter whether you include or not include 2 pi. So you're going around the circle, right? And you want to find what's the length. Well, let's go ahead and do that. So x prime is negative 3 sine t. Y prime is 3 cosine t, right? So if you were to find that ds thing, which in this case, because it's a two-dimensional, is just x prime squared plus y prime squared, and then you're supposed to multiply by dt. Okay, so then what will happen is that I'm going to take my x prime, which is negative 3 sine t. I'm going to square that, and then I will also square y prime, and then I'm going to add them up. And let's see what happens. So when we square a negative, remember it goes away. So this will become 9 sine squared t plus 9 cosine squared t, and then dt. However, if you factor out 9, you will see that you just get sine squared plus cosine squared, which is that first trigonometric identity that everybody knows that that's just 1. So I get square root of 9 dt, which is 3 dt. Okay, so if I were to integrate this from 0 to 2 pi, and I just got ds, and remember this is just the arc length, meaning like basically the circumference of the circle, this will be 3 dt. Now integrating 3 just gives you 3t, and then you substitute 0 to pi, and then you've got 2 pi, you got 2 pi multiplied by 3, in other words 6 pi. Now remember that the circumference for a circle formula is 2 pi r. Hopefully you remember that from geometry maybe. And that's exactly what we got, because our radius was 3. So we would have gotten 6 pi if we knew the formula, but I just showed you that that's also true. Now, if you are not just integrating one, so I'll take a look at this specific example right here. So this is integrating 1 plus x squared y with respect to the arc length. So the circle is radius 6, so this would be 6 cosine t, and then this should be 6 sine t. Now, because it says upper half, that would be from 0 to pi, right? So we're not going all the way around, we're stopping at 180 degrees. Now, finding and simplifying ds would be exactly the same thing that I just did over here. The only difference is instead of 3 that I had, this is 6. So I'm not going to repeat the calculation, so this is just going to be 6 dt. Now, this part is going to be different. So what's going on with the plugin in parameterization? So here we're not integrating 1. We're integrating 1 plus x squared y, right? And we just found that ds, so we make the parameterization, we just found that ds is 6 dt. But what about here? Like, what's going to be our integrand? Because again, this is not arc length. We're integrating some function. So what you do there is you're going to plug your parameterization. So wherever you see x, you're going to put 6 cosine t. So I'm going to get 1 plus 6 cosine t, and I square that. And then I multiply that by y, which is 6 sine t. Okay, so simplifying that would be 1 plus, now this is 6 squared times 6, this is like 6 cubed. I think that would be 216 cosine squared t sine t. So let's see if it accepts it. So I think it's going to be cosine squared t sine t. Okay, so this is going to be that. Let's submit it. Okay, so that is correct. And then to evaluate the integral, we actually have to integrate. So let's go ahead and integrate. So this is from 0 to pi. We're integrating 1 plus 216 cosine squared t sine t. And then we are multiplying that by ds, which was just 6 dt. Okay, so let's see what happens. Now, when we integrate 1, we're just going to get, and let me just pull that 6 out and just multiply by it, the whole thing. So this is going to become integrating 1, that'll be t from 0 to pi, so that's just going to be pi. Now, I have to show you what happens, and then this is going to be 216, but I want to show you how to integrate cosine squared t sine t dt. So if there was no sine t, then the way you would integrate that is using something called half-angle formulas for cosine squared. But if you do have not just cosine squared, but also sine in addition, that is integrated by a substitution. Okay, so unless the powers of cosine and sine are all even and there is nothing odd there, then you use a substitution. So substitution should be whichever power is not odd. Like, and sometimes they're both odd, then you have a choice of either one. But here, the sine t has an odd power 1, so you take the other one as your substitution. So this would be cosine t, and du would be negative sine t dt. So this part right here, that's actually going to be negative du. This would be u squared. And integral of u squared du with a minus will become negative u cubed over 3, right? And then I just substitute cosine t in for u. So now let's go ahead, go in here. So this is going to be minus. And then it's going to be u, which is cosine cubed t divided by 3. Okay? And again, I'm substituting 0 and pi in here. All right, so let's just evaluate what we get. So from here, we get pi. Then here we get 216 over 3. Now let's see what happens when we substitute a pi for cosine for t. So cosine pi is negative 1. When you cube it, it's going to be negative 1. And then you subtract. What happens if you substitute 0? So substituting 0 will give you cosine 0, which is 1. Okay, so this looks like this is going to be negative 2. So my final answer is going to be 6 times pi, then plus, well, 2 times 216. Man, I don't want to lie, so I don't want to do this in my head. So 432 over 3 is what I got there.